Okay, this is question number 14 of exercise 6.5. You are given a triangle ABC in which DB is 3 times CD. Okay, this is a point D and AD is perpendicular to the base CB. So this is CD here and this is 3 times that. So DB is taken as 3 times CD. And what we need to prove is that twice of AB square is twice of AC square plus BC square. Okay, so both sides there are squares, so it is a question based on Pythagoras theorem. So what we need to find is first the value of AB square. So we are going to take this triangle ABD and AB square will be AD square plus BD square, right? This is the hypotenuse, so AB square equal to AD square plus BD square. Now instead of BD we can replace it with 3 times CD. Why? Because it is given to you that DB is 3 times CD. So 3 CD whole square we get 9 CD square here. And here AD is not required, I require AC. So what I'm going to do is that replace AD in terms of AC. So how will we do that? Take the triangle ADC. AD square can be written as AC square minus CD square, right? AD square is AC square minus CD square. So I'm going to replace AD square as AC square minus CD square. So when you solve this, 9 CD square minus CD square, you're getting 8 CD square. So you got one equation like this. Now if you look at what we want to prove, it is twice of AB square. So in order to get 2AB square, I'm going to multiply this entire equation with 2. So I'll get 2AB square, 2AC square and 16 CD square. Now 16 CD square can be written as 4 CD whole square. I'm not going to disturb this because this is what I want. Already I've got this. Only I have to get the here BC square. So 16 CD square I have replaced with 4 CD whole square. Now look at the diagram very carefully. This is already CD and DB is 3 times CD. So if you add CD and 3 CD, this total length is going to be 4 CD. That means 4 CD is equivalent to BC. So instead of 4 CD, I can replace with BC. So this will become BC whole square, that is BC square. So we get the required statement that 2AB square is 2AC square plus BC square, right? Then question number 15. What is given is it's an equilateral triangle. Now this is an important question. You can mark this important. So if it's an equilateral triangle, all the sides are equal. So AB, BC and CA are equal. BD is given 1/3 of BC. So I am taking a point D here and this length BD is 1/3 of the total. So BD is 1/3 of BC. Now this is again a question based on Pythagoras because I have to prove that 9AD square is 7AB square, right? Both sides there is squares. So I need to draw a perpendicular because there is no right angle in the question as of now. So if I want to apply Pythagoras theorem, I'll have to draw a perpendicular and that perpendicular is AE. So draw AE perpendicular to BC. Now once we draw the perpendicular, we have right angles. So how do we find AD square now? AD square will be, take this triangle ADE, AD square will be AE square plus DE square, right? In triangle ADE, AD square equal to AE square plus DE square. Now AE square is not required. I want AB square. So I will replace AE square in terms of AB. How will I do that? AE square will be written as AB square minus BE square, right? AE square can be written as AB square minus BE square. So I have written that here. And DE can be written as BE minus BD, right? DE can be written as BE minus BD. So I have written instead of DE, BE minus BD. And there's a square, so I put that. Now this is A minus B whole square, so that will become A square plus B square minus 2AB. The minus BE square and plus BE square will get cancelled. And you're getting this AD square equal to AB square plus BD square minus 2BE BD. Now instead of BD, I can write 1/3 BC, right? So wherever there is BD, I have written 1/3 BC. And instead of BE, I can write half BC. Why we can write half BC? Because in an equilateral triangle, the altitude always bisects the base. So this is the altitude because it's 90 degrees. So this bisects the base. So instead of BE, I can write half BC. So here 2 and 2 gets cancelled. So we get AD square equal to AB square plus 1/9 BC square minus BC square upon 3. Now it's an equilateral triangle. I don't require BC. I require AB. So wherever there is BC, I am replacing with AB. So I'll get AB square upon 9 minus AB square upon 3. Then I am taking the LCM. LCM is 9. So this will become 9AB square plus AB square. 3 goes 3 times. So this will become 3AB square. 9 plus 1 is 10. 10 minus 3 is 7. So we get 7AB square. And this 9 will be cross multiplied that side. So we get 9AD square. So hence we get 9AD square equal to 7AB square.